Good afternoon, class. And at this point, we are experiencing load shedding during your maths lesson. So I'm doing a pre-recording on this lesson that we're doing in this video. So we're looking at the exponents and surds. And at this point, we're looking at the examples for exercise 1.9. Okay. Examples on page 1.9 is on page 17. Yes, the examples are on page 17. Okay. So we're looking at operations involving surds. Okay. So we know that P plus P is going to be 2p. Okay, as you can see, they are like terms. Likewise, when we're dealing with surds, we're going to look for square roots or radical form that's all the same. So you got square root 3 plus square root 3 would simply be 2 root 3. Okay, so 2a plus 4a or 4a plus 2a is going to give us 6a. So 4 root 5 plus 2 root 5 is going to give us 6 root 5. Okay, that is as if we had variables there. Okay. So if you look at number 5 says you got the square root of 2 plus the square root of 3. If you add p plus a, that is going to remain p plus a. Why? So they are unlike terms. Likewise here, you got the square root of 2 plus the square root of 3. They are unlike roots. So it remains root 2 plus root 3. Okay. Let's carry on. We are still on page 17. So the question says simplify the following. Give your answer in simplest surd form. Okay, so now as we did with like terms, we're looking for roots that are the same. So 2 root 3 is the same as 3 root 3, negative root 2, plus 5 root 2 are again like terms, so we like roots. So 2 root 3 plus 3 root 3 is going to give us 5 root 3, negative root 2 plus 5 root 2 is going to give you positive 4 square root 2. And as you can see, they are unlike, so I'm not going to add them there. Let's look at number 2, the square root of 52. The square root of 50. So with the question we should be asking ourselves, what are the biggest perfect square that is divisible by 52? And what are perfect squares? We know it's going to be 1, 4, 3 squared is 9, 4 squared is 16, 5 squared, 6 squared, 7 squared, and so on. So the largest perfect square that is divisible by 50 is going to be 25. So it's 25 times 2 minus 3 root 2. The square root of 25 times the square root of 2 minus 3 root 2. The square root of 25 is 5 root 2 minus 3 root 2. What do we notice? Again, we have like roots there. So 5 root 2 minus 3 root 2 is going to give us 2 square root 2. Okay. So we're still looking at the examples. And the examples are on page 17. So here we are told simplify the following, give your answer in simplest surd form. So number 3. So we can see that we got 2 root 12 minus 75 plus the square root of 27. So the largest perfect square divisible by 12 is 4. So it's 2 times 4 times 3 minus 75 is going to be 25 times 3 plus 27 is going to be 9 times 3. The square root of 4 is going to be 2. The square root of 4 is 2. root 3, the square root of 25 is 5 root 3, square root of 9 is 3 root 3. So of course this is going to give us 4 here, so it's 4 root 3 minus 5 root 3 plus 3 root 3. So 4 root 3 minus 5 root 3 is negative root 3 plus 3 root 3 is 2 square root 3. Okay. Let's look at number 4. Number 4 is either I can multiply that root 2 in, or we can change it to simplified third form first. Okay. If we multiply it in, it's going to be root 2 times root 50 is going to be root 100 minus 3 root 2 times root 8 is root 16. Square root of 100 is 10 minus 3 times the root of 16 is 4. So it's 10 minus 12, which is negative 2. Okay. If we had gone the other way, we had converted to simplified third form first, so it's root 2 into the square root of 25 times 2 minus 3 root 4 times 2, which gives you root 2 into the square root of 25 is 5 root 2 minus square root of 4 is 2 times that 3 is going to be 6 root 2. So it's root 2 into 5 root 2 minus 6 root 2 is negative root 2. Positive times negative is negative. Root 2 times root 2 is the root of 4, which is 2. Okay. Let's carry on with our lives. Number 5. Question 5. Again, we're going to multiply the first and the last. Okay, that's the conjugate period. So 2 times 2 is 4. Positive times negative is negative. Root 3 times root 3 is root 9, which is 3. 4 minus 3 is 1. Number 6, it's a binomial square. So we square the first term, it gives us 4. That times 2 is going to give you negative 4 root 3. And negative 3 squared is positive 3. And of course those are like terms, these are 7 minus 4 root. If I had gone the other way, if I had applied the other method, I would have written out twice. For those of you that want to apply the binomial square, you're not comfortable. 2 times 2 is 4, 2 times negative root 3 is 2, negative 2 root 3, negative root 3 times 2 is negative 2 root 3, negative root 3 times negative 3 root 3 is positive 3. 3 plus 4 is 7 of course, minus 2 root 3 minus 2 root 3 is negative 4 square root 3. Both ways you get the full multiple. Okay. Let's go to the next question, which is number 7. Okay, one of two ways of doing it. If you want to apply the square immediately, it's 2 squared is 4 times root 3 squared is going to give you 3, which is 12. Or we could have said 2 root 3 squared is going to be 2 root 3 times 2 root 3. 2 times 2 is 4, root 3 times root 3 is root 9 or 3, and 4 times 3 is 12. Okay. So with that you should be able to do exercise 1.9. Okay, you'll do the odd numbers and then the even numbers is for homework.